An object moving with a speed of 6.25 meters per second is decelerated at a given rate, at a rate given by dv by dt is equal to negative 2.5 root v, where v is the instantaneous speed. The time taken by the object to come to the rest would be 2 seconds, 4 seconds, 8 seconds, 1 second. This is an integration problem, clearly. We know how this velocity varies with time. So we basically know dv by dt. Let us separate the variables. So we get dv by root v equal to negative 2.5 dt. And if I bring in the limits, what should the limits be? T equal to 0, velocity is 6.25. Okay, t equal to 0, velocity is 6.25. Now we want to determine the time when final velocity to come to rest, that means the final velocity is 0. Okay, can you solve this and tell me the value of time? Let us do it. What is the integral of 1 upon root x with respect to x? It is 2 root x, right? It's 2 root x. So in this case it will be 2 root v, lower limit 6.25, upper limit 0, equal to minus 2.5, integral of 1 with respect to t will be t from 0 to capital T. Have you followed till this? What is the upper limit on v? 0, because we want it to come to rest. Okay, so there is no need if we to substitute it because it is anyways going to give us 0. But what it will do is it will give us a negative sign. And what will be root of 6.25? It's 2.5. Okay, and again here capital T minus 0, so that's capital T. So this term will cancel this 2.5, and how much will t be then? Equal to negative, negative makes it positive. So time t will be 2 seconds. Time t will be 2 seconds. Now my question to you is, if we know this data, is it possible to find the distance that the particle travels or the object travels before it comes to the rest? Distance traveled before coming to rest. Can you find it, or can you tell me how to find it? I will do the mathematics for you. Of course kinematic, of course equations of kinematics, but any suggestion for that? Suppose the particle starts at 0. Let x be 0, v be 6.25 at t equal to 0. Yes, Rajat, you were saying something. Okay, I'll help you out. Because we want to find the distance traveled, we may use this particular formula for acceleration, dv by dx into dx by dt. Okay, and then for dx by dt, let us replace it by v itself. Okay, now look what has happened. We have transformed our variable from time t to displacement or position x, correct? Which then gives us v dv by dx equals negative 2.5 root v. Have you understood this? V dv by dx equal to negative 2.5 root v. Okay, fine. So cancel root v there, so it will bring root v here, negative 2.5 dx. Again integrate, limits on V are not going to change. Limits on V will be 6.25 position 0, position X, speed 0. 2 by 3, correct? No, not cube root. Square root of the cube. Yes. And on this side it will be negative 2.5 into X. Right? Negative 2.5 into X. Okay. Well, this is taking us a bit more space than required, than we had thought. Anyways, let's shift it. Acha. Let's continue with the same sum. Now, before I cube, I know that 6.25's square root is 2.5. Okay, so let me write it like this. 2 by 3. Let's get rid of the 0 first, which gets us a negative sign here. Into, okay, let's not write into. 6.25 square root is 2.5, and then we are going to cube this. Is that clear? 1 upon 2, yeah, that's root, right? Okay. So this will make it square after cancelling this. So how much will X be? X will be 2.5 squared into 2 upon 3. Okay, you can calculate it. (25 by 6). Do we have units here? Okay. Oh yes, we do. Meters. Okay. So this is meters. So after traveling 25 by 6, 4 point something, the particle will come to rest. Okay. So this is a modified question. Both X and T can be found out.